Section 3.9, again, two topics, tower functions and more examples. Take a review about what we learned in the last class. A, logarithmic differentiation means use log to simplify a function before computing its derivative. Functions involving products, quotients, or powers can often be simplified by taking an logarithm. B, the following four properties about log are the properties that we use in logarithmic differentiation. Property number one, log can reduce a product to a sum. Number two, log reduces a quotient to a difference. Number three, log reduces a power to a product, the power times log. Number four, natural log of e to m is m. E to natural log of m is m. In these two formulas, natural log and e, they cancel each other. Now, topic one, tower functions. Recall that x to a is a power function. In a power function, the base is a variable and the power is a constant. The formula to compute the derivative of a power function is this. Derivative of x to a is a, the power, times x to a minus 1. When we switch x and a, then we get this function. This function is called an exponential function. In an exponential function, the base is a constant and the power is a variable. The formula to compute the derivative of an exponential function is this. Derivative of a to x is equal to a to x times natural log of a. When the base and the power both are variables, the function is called a tower function. For a tower function, no formula is available to compute its derivative. Some people may apply the formula for power function to compute the derivative of a tower function, but that is wrong. In general, a function of this form, the base is a function and the power is also a function. A function of this form is called a tower function. To compute the derivative of a tower function, we have to use logarithmic differentiation. Now, let me show you some examples about how to compute the derivative of a tower function. Example 1. Let y be this function, x to x. Find derivative of the function. To compute the derivative, I use log to simplify the function. I take natural log on the both sides. Then I have this equation. Natural log reduces a power to a product, the power times lateral law. So I can bring down the power x to the front to get this equation. Now, take derivative on the both sides of the equation. Then I have this equation. The derivative on the left side contains two different variables, x and y. I cannot compute it directly. By the chain rule, I write this derivative as the product of these two derivatives. To compute the derivative on the right-hand side, I use the product rule because the function is x times lateral log of x, a product. By the product rule, this derivative is this. So I have this equation. Derivative of lateral log of y with respect to y is 1 over y. dy dx is y prime. X derivative is 1. Lateral log derivative is 1 over x. I have this equation. X times 1 over x is 1. I have this equation. Now move y to the right-hand side. I have this equation. In this example, I know y, I know the function. The function is x to x. I plug in x to x in the y here, then I have this equation. This result contains only x, no y. This is the answer to this example. This example has a second solution. In this second solution, I transform the tower function into an exponential function by this formula. In this formula, I set m to be x to x, x to x. Then I have this equation. Lateral log of x to x, I can bring down the power x to the front. I have this equation. Now, take derivative on this exponential function. I simplify the function by introducing an intermediate variable u. I let u denote x times lateral log of x. Then the function becomes e to u. Derivative of e to u with respect to x. This derivative is not computable directly. By the chain rule, I write this derivative as the product of these two derivatives. Derivative of e to u with respect to u is e to u. Now, plug in x times lateral log of x in the u here. Then I have this equation. To compute this derivative, I use the product rule. Then I have this equation. Derivative of x is 1. Derivative of lateral log is 1 over x. Now, simplify this expression. E to x times lateral log of x is equal to x to x. So I plug in x to x here. X times 1 over x is 1. This is the result to this example. Example 2. Find the derivative of this tower function. The base is 8 times x. The power is lateral log of 8 times x. To simplify the function, I let y equal to the function. Take lateral log on the both sides, then I have this equation. Lateral log of a power is equal to the power times lateral log by formula. In other words, take the power to the front to get this equation. Lateral log of 8 times x times lateral log of 8 times x is lateral log of 8 times x squared. Lateral log of 8 times x is lateral log of 8 plus lateral log of x, because lateral log reduces a product into a sum. This function is simple enough. I don't think I can further simplify this function. Now, next, I take derivative on this equation. Take derivative on the both sides, then I have this equation. To compare this derivative, I want to simplify the function. I let u below lateral log of 8 plus lateral log of x. Then the function becomes u squared. Apply the chain rule to this derivative and to this derivative. Then I get this equation. Derivative of lateral log of y with respect to y is 1 over y. Derivative of y with respect to x is y prime. Derivative of u squared with respect to u is 2u. Now, remove u, the intermediate variable. Plug in lateral log of 8 plus lateral log of x in the u here. Then I have this equation. Now, this derivative is, the function is a sum. So apply the summation formula. This derivative is this derivative plus this derivative. Lateral log of a is a constant. Derivative is 0. Lateral log of x with respect to x is 1 over x. So I have this equation. Simplify the right side a little bit, then I have this equation. Move y to the right hand side, I have this equation. Now, we know what is y in this example. Y is this function. Plug in this function in the y here, then I have this equation. This is the result of derivative of y. Solution 2. In this solution, I want to use this formula to compute the derivative. This formula says that m is equal to e to lateral log of m. E and lateral log cancel each other. Then the right side is the left side. By this formula, I transform the tower function into an exponential function. I raise up the tower function by inserting e to the base. Then I have this equation. Log of a power, this is a power, is equal to the power times log. I can take the power to the front of log to get this equation. Lateral log of ax times itself is lateral log of ax squared. Lateral log of 8 times x is lateral log of 8 plus lateral log of x. Lateral log reduces a product into a sum. Now, take derivative on the tower function. Because of this equation, derivative is equal to the derivative of this exponential function. To compute this derivative, I want to simplify the function. I use u below the power. Then the function becomes e to u. Now apply the chain rule to compute this derivative by inserting du to the bottom and to the top. Then this derivative is the product of these two derivatives. Derivative of e to u with respect to u is eu. Now plug in lateral log of 8 plus lateral log of x squared in the u here. Then I have this equation. To compute this derivative, I use the chain rule again. I let w below the base, lateral log of 8 plus lateral log of x. Then the function becomes w squared. Now, to compute this derivative, because x and w are different, I need the chain rule. Write this derivative as the product of these two derivatives. Derivative on w squared with respect to w is 2w. Now remove w. Plug in lateral log of 8 plus lateral log of x in the w here. Then I have this equation. To compute this derivative, I apply the summation rule. Lateral log of a is a constant. Derivative is 0. Lateral log of x. Derivative is 1 over x. Then I have this equation. Now simplify this expression a little bit. Then this is the answer to this example. Topic 2. More examples. Example 1. Use logarithmic differentiation to find the derivative of this function. The standard solution to compute the derivative of this function is apply the quotient rule first, because the function is a quotient. When I compute the derivative on the top, I use the product rule. When I compute the derivative of e to negative x, I use the chain rule. And when I compute derivative of cosine square, I use the product rule, because cosine square is cosine times cosine. And also I can use the chain rule to compute the derivative of cosine square. Now, in this example, we need to use logarithmic differentiation to find the derivative. Namely, use log to simplify the function first, then compute the derivative. Now, the solution to this example. Take logarithm on the both sides of the equation and simplify it. Take logarithm. Usually take lateral log. Take lateral log on the both sides of this equation. Then I have this equation. Because this function is a quotient, and lateral log reduces a quotient into a difference. I have this equation. This function is a product. Lateral log reduces a product into a sum. Then I have this equation. Lateral log and e cancel. Then the first term becomes negative x. The second term, the function is a power cosine square. Lateral log of a power is power times lateral log. That is, I can move the power 2 in the front to get this term. Now, about this function, I cannot further simplify this function. Next, I take derivative on the both sides of this equation. Take derivative on the left side and on the right side. Then I have this equation. Apply the summation rule and the subtraction rule. Then I have this equation. Next, I want to simplify the functions. This function, and this function. I let u below f of x, w below cosine of x, s below x squared plus x plus 1. Then I have this equation. To compare lateral log of u with respect to x, I need the chain rule. I insert du to the bottom and put a du on the top. Then this derivative is the product of these two derivatives. Similarly, by the chain rule, I write this derivative as the product of these two derivatives, and write this derivative as the product of these two derivatives. Now, lateral log of u derivative with respect to u is 1 over u. Lateral log of w derivative with respect to w is 1 over w. Lateral log of s derivative with respect to s is 1 over s. Remove u, w, and s. They are intermediate variables. Plug in f of x in the u here. Then I get this term. Plug in cosine of x in the w here. Then I get this term. Plug in x squared plus x plus 1 in the s here. Then I have this term. Derivative of f with respect to x in other notation is f prime of x. Derivative of cosine of x with respect to x is negative sine of x. Derivative of x squared plus x plus 1 with respect to x is 2x plus 1. Then I have this equation. simplify this term and this term a little bit, then I have this equation. Move f of x to the right side, then I have this equation. About function f, in this example, I know function f. Function f is this function. Plugging this function in f here, then I have this equation. The right side of the equation is the answer to this example. Example 2. Use the definition of derivative to evaluate this limit. This limit is the derivative of some function f at some point a. To determine the function f and the point a, I compare this limit with the definition of derivative. Comparing this limit and this limit, I can see that the function f is lateral log of x. And the point A is e to the fifth. Therefore, the given limit is derivative of lateral log of x at the point e to the fifth. Derivative of x by formula is 1 over x. Plug in the point e to the fifth in x, then this number is this limit.